kan siya tlan turin mizo tongin kan sailok live telecast om dona wang kan trudante moi lo om thei ang khachutle min kan inveng donya om. Good morning, everyone. I would like to extend a warm welcome to all our distinguished guests, faculty members, and students who have gathered here for the second day of the two-day International Symposium on History of Astronomy of the Mizo People. It is indeed a pleasure to have you today. For the formal welcome address, may I call upon our chairman of this session, Engineer H. Somliana, Chief Scientific Officer, Directorate of Science and Technology, Government of Mizoram, on the dais, please.
Good morning, all of you. It is my great pleasure to welcome you all here in the 2 days International Symposiums on History of Astronomy of the Mizo People at the second day, at which we have public lectures, astronomy. Astronomy and space are for everyone. So this is your astronomy and the place is yours. And I would like to welcome Dorpui School of Science and Technology, Dorpui, Mount Carmel School, Chalklang, St. Joseph Higher Secondary School, Ramdun North, St. Paul's Higher Secondary School, Klang Nuam. Lucky to have you here, and I see that you all are the best schools, the best students in ISO, so we are very proud to have you here as an audience, And Physics Department of Mizoram University and Pachunga University College. Today we are having a fantastic lecturer, or speakers rather, Dr. Martin George, who would be telling us all about the astronomy and the space. And you would be very lucky to listen to me very carefully. And I hope you would be gaining much about the astronomy and the space. Whatever questions or queries you have, you can ask, and there would be an interaction there. So I also welcome Honorable Vice Chancellor, MZU, and other invitees who have come here at the symposiums organized by Department of Physics, MZU, and Mizoram Science Center. So I once again welcome you here to enjoy the symposiums and have a fruitful interactions here. Thank you.
I now request the Director, Office of International Affairs, Mizoram University, Professor H.K. Laldinpui Fente, to kindly introduce our speaker.
Good morning, everyone. Good morning, everyone. Thank you. It was the 20th of November in 2022 at the university in Thailand called Siam University, where the Association of Universities of Asia and the Pacific had a program for the youth of Asia and Pacific region universities, where Dr. Martin George was the speaker, was the invited speaker. And we were, as a participant, 5 scholars and teachers from Mizoram University. We were so impressed about what he said although we were from the field of psychology, from the field of education and biotechnology, nothing to do with astronomy, we were overblown by his speech, and overwhelmingly convinced us that astronomy is really for everyone. So we decided then that we would speak to our Honorable Vice Chancellor and convey to him about our impression of his talk. Then it was Professor Rath, the acting Vice Chancellor of Mizoram University, who insisted that we must invite the great astronomer to Mizoram University, not only to talk to our university students and faculty members, but also have a tie-up with the Directorate of Science and Technology, principally the Science Center, to collaborate and, of course, offer this great talk and knowledge to the students of science in Mizoram. We wanted to do for the entire streams of studies. However, the whole is not so large, so we selected schools, and I'm very, very glad to present to you the great astronomer, Dr. Martin George. There is a whole lot of information about him on the internet, and his speeches, his talks that has been aired on YouTube, and that can be read. So that I don't take too much of your time in introducing him, I'm going to read out what I have, the latest of him, about him. So Dr. Martin George was born in the United Kingdom and educated in Tasmania. He lives in Tasmania now, so he is both an Englishman as well as an Australian. He is principal astronomer at the Ulverston Planetarium in Tasmania, that is in Australia, and has communicated astronomy and space topics and worked in the planetarium industry for over 40 years. He is a fellow and former president of the International Planetarium Society, the World of Planetarium Professionals, and chair of its International Development Committee. Currently, Dr. Martin is working with planetariums in India and Thailand to encourage the formation of planetarium associations in those countries that can be affiliated with International Planetarium Society. And at this moment, I would like to take the opportunity to say hello to the other Indian fellows in different planetariums in the country, especially in South India, who are joining in on YouTube as it is being streamed, as the program here today is streamed live on YouTube, that is in Mizoram University's channel. He is a member of several other astronomy-related professional organizations, including the International Astronomical Union. Dr. Martin writes regular newspaper articles and makes frequent appearances on radio and television to discuss exciting events in astronomy and space research. He is interviewed monthly in Australia on ABC, Northern Tasmania, and Launceston City Park Radio in Tasmania, and fortnightly, nationally on ABC local radio. He has kept close links with the University of Tasmania and has on many occasions presented undergraduate courses in astronomy at the university's Launceston campus. He frequently speaks to community groups and the public on astronomical topics. Dr. Martin is passionate about astronomical history. He has published papers on the history of low-frequency radio astronomy in Tasmania and co-authored papers on the history of observation of eclipses in Thailand. I'm very, very honored and proud to present to you Dr. Martin Richard George to come and deliver the public talk.
Thank you. Great. So, Siri, if we put the HDMI in there, if we put the...
In the words of Socrates, the philosopher, man must rise above the earth to the top of the atmosphere and beyond, for only thus will he fully understand the world he lives in. Astronomy compels the soul to look for upward and leads us from this world to another.
That's it. Okay, there we are. Thank you.
So the floor is yours.
Thank
Dr.
you.
Martin.
It's a very nice shiny floor up here, actually. It's great. Thank you very much for that lovely introduction, Professor Fente, and it's wonderful to be here. I've really enjoyed my time here so far. I haven't got very long to spend here in Mizoram, but what I've seen so far has been absolutely wonderful. So thank you for having me here as your guest in your state and in your city. Professor Fente mentioned a few moments ago that we first met when I gave a talk about astronomy is for everyone in Bangkok just a few months ago. And I've made a slight change to the talk. I now say astronomy and space are for everyone. And you might think, isn't that the same, astronomy and space? Well, actually, there's a rather interesting distinction here. And I'll be mentioning that again shortly. But let's start off by taking a look at part of the sky that you cannot really see clearly from here in Mizoram. I'm looking now out toward a very famous group of stars. It's called the Southern Cross. Has anybody heard of the Southern Cross? The constellation, the star pattern? It's on our Australian flag. And next time you have a look at an Australian flag, you'll be able to see the shape of the cross just there. But the reason I'm showing you this picture is because not far from there, over to the left, do you all see the two bright stars? We call them the pointers because they look like they're pointing to the Southern Cross. But the special thing about these is the one on the left. It's the one that we call Alpha Centauri. And the special thing about that is not just because it's a triple star system. We can't see the three separately just by looking up to the sky, but the reason is that it's the closest star system to our sun. I know you all would realize, of course, that the sun is a star. You would all know that. But that star called Alpha Centauri, that triple system, it's the closest, the closest one to ours. And I'd like you to try a little experiment with me before I tell you how we know how far away that star is. I'd like you to all hold out your hands in front of your faces. Okay? I'd like to see about 400 hands. Wonderful. Okay. Now I'd like you to close one eye. It doesn't matter which one. And I'd like you to now point to something. It could be something on my screen. It could be me. It could be this microphone. Subject. Now I'd like you to change eyes. Switch. No, of course it didn't move. But what I've just shown you is the first thing I need to show you to talk to you about how we measure the distances to the stars. But I'm going to try explaining it with this particular diagram first of all. Now, you all love science and maths, don't you? Yes, that was mostly from that side of the room. This side of the room likes science and maths as well? Yes. Very good, excellent, okay. And probably in maths at school, you've been solving triangles, right? Working out the lengths of the parts of a triangle and all the angles. Have you all done that? Yes. Right. Do you do trigonometry? Yes. Excellent, right. And when you were learning about this, did you think to yourselves, oh, why do we have to learn this? Yeah, right, okay. Well, I'm going to show you why you needed to learn that. First of all, you won't always be measuring the distance to a tree across the other side of a river by drawing a triangle. But triangles are really, really important things to study. I was speaking with Professor Fente just a few hours ago about the importance of triangles in maths and all sorts of other things. But how do we measure the distances to the stars? Well, actually, we use the same method. Did you notice, I'll just go back to that, did you notice there's what we call a baseline? That baseline, when we did the thing with the finger, was the distance between your eyes. We looked at your finger from two different directions. So we had a triangle to solve. How do we measure the distances to the stars, though? We need to move a telescope, don't we? Or do we? From one end of the baseline to the other to make the triangle. How far can we move a telescope? Would anybody like to guess how far we can move a telescope? This is the quietest moment in the room this morning so far. Well, I'll tell you, without doing anything, we can move a telescope 300 million kilometres because the Earth goes around the sun. So, if we look at a star, for example, in January and look at it again in July, it's going to look like it's shifted, just like the end of your finger did. And so we can use our knowledge of how big the Earth's orbit is to work out the triangle, to draw the triangle and work out the angles. And we can use that method to measure the distances to thousands and thousands of the nearest stars to us. Not the more distant ones, and not galaxies like this one. We live in a galaxy like this, but we can't use that method to look at or measure the distance to those stars in that galaxy because the angle would be too shallow. We would not be able to measure it because the stars are too far away. But there are other methods that I won't go into today, but they build on the first part of it, the construction of a triangle, and then work to greater and greater distances. Now, of course, when we look up to the sky, we can have a lot of fun looking at star patterns, and I'm sure some of you have done this before. Some of you might have heard of this particular one. It's called Orion, the Hunter. And there are 88 of these on our standard charts today. They're all based on a lot of imagination. Actually, a bit too much imagination in many cases. Orion does actually look a bit like a man if you use plenty of your imagination. But on those standard star charts, they're just the normal ones that we find on every star chart today that is generally published, that follows the agreements by the International Astronomical Union. But there are all sorts of other patterns that we see in the sky. And these have been meaningful to people in different countries and cultures. And this particular one that I'm showing you at the moment is called the emu in the sky. And it's the native Australian people, the Australian Aboriginals, who we call the first Australians, who were there for thousands and thousands of years before people came from other countries. And they saw that the Milky Way, that milky glow formed by the countless stars in our galaxy, had dark patches in it. And I wonder if you can see this really dark patch just here near the Southern Cross. It's called the coal sack because it makes people think of a sack of black coal, but it is actually the head of an emu. Has anybody seen an emu before? Okay, it's a bird that we have in Australia. It's a little bit like an ostrich. You might have heard of ostriches before. Anyway, here we can see the pattern of the emu in the sky, formed by the darkness in the Milky Way, not the light. And that darkness is made up of clouds of dust in our galaxy, places that we look at but can't see the brighter parts beyond. We can't see the stars beyond that. So different people of different places around the world have thought about different patterns in the stars. And you might like to do that yourselves. When you look up to the stars, you might even do a better job than some of these astronomers have over the ages. Because quite frankly, I've never been able to see the shape of a unicorn in that group of stars. No, it just doesn't look like a unicorn to me. In any case, unicorns don't exist, as you all know. I just better say that right now. But yeah, a lot of imagination's been used there. But I had a delightful thing happen yesterday. I was presenting a talk here yesterday, and we had a wonderful symposium about the astronomy of the Meso people. And I managed to get a copy of a wonderful book that's in its second edition now about the star stories from Mizoram. And it's an absolute treasure that I'm going to take back to Australia. I would certainly love to have an English translation one day, and I've already asked about getting that done. But this is very meaningful to me because it's another example of how people in different parts of the world have thought about the stars and the wonderful stories that they have. Of course, many of these stories are not scientific stories. Those constellations, the star patterns like the Southern Cross and the unicorn, they don't actually have a scientific value, but they have a human value that connects us with the sky, and that is so important. Let's move on to something a little bit more practical. I found this advertisement in a scientific magazine just a few months ago, and that is an illustration of the fact that there are many different science careers that you can follow. Now, I think many of you are doing science in year 11 and 12, is that right? Yeah, and you like that, of course, with not just the maths, it's the science and everything you like. But your career in science, your knowledge and your learning of science can take you to all sorts of places. And one interesting thing that we do in the planetarium field, where we're talking to people about astronomy and space all the time, is that we get a lot of inquiries about when the next full moon is or something like that, because people like to know these things. So we get asked about this kind of thing. But maybe some of you like watching movies where the moon appears in the sky. Unfortunately, sometimes they get the moon the wrong way up. This is the way it appears from the northern hemisphere, not the southern hemisphere. So the people making the movie just use a bit of video and they don't understand what they're doing. And look at this one. The moon can never appear like that. That's how we would see it if it was in a mirror. But we see lots of pictures published like that. Totally impossible pictures. So we would love these movie makers to talk to us a lot more about what to put in their movies so they don't make these mistakes. Now, some years ago, there was a famous movie called Poseidon. It's about a ship that turns over because of a big wave, and the people have to try to escape from the ship. And this big wave comes through at midnight. And here's the trailer of the movie showing the full moon rising at midnight. No, it doesn't. No. The full moon rises at about the same time as sunset. Now, most people would not think about that as being wrong. But I look at it and I think, oh, no. Yeah. Okay, a bit more practical. I hope all of you have one of these either at home or at school. Are these popular here, globes of the Earth, in your classrooms? Yes? Okay. Everybody, if you do not have a globe of the Earth at your school, after my talk, ask your teachers to make sure there is one there, okay? And you can blame it on me, because these are so important, so educational. Now, you can use a globe of the Earth to learn a lot about latitude and longitude, the angles around the Earth, and the angles above and below the equator. And it tells us where we are. I'm sure you've all used GPS before. You can get latitude and longitude readouts on that GPS machine. But I find that a lot of people don't understand what latitude and longitude really are. I think it's really important to learn that. And why has that got anything to do with astronomy? Well, it's because we use these things on other planets as well. And some of you people here today, how old are you all? About 15, 16, 17? Yeah. Some of you might be the first people to walk on this planet, and you'll need to know where you are. So knowing what latitude and longitude are all about, as we apply it to even other planets, is going to be very useful to you. So if you're learning this now and you're thinking, why are we learning this? Now you know. You need to know where you are. I'd like to tell you a few really inspirational stories to show you how, in many cases, individual people have contributed very, very greatly to astronomy. And I'm going to start off with this gentleman. His name was Karl Jansky. And he was working in the early 1930s, about 90 years ago, because he was trying to find out the source of radio interference. In other words, radio signals when people were trying to talk to each other on radios, and there was a static, a buzz, a noise in the background that was very annoying. So he built a special radio antenna to try to work out where this noise was coming from. And he made an amazing discovery. He discovered that this radio interference reached a peak every 23 hours and 56 minutes. Yes. Can I see the wonderful look on all your faces? About 23 hours and 56 minutes. What is it? It's the rotation period of the Earth. Yeah. And that meant that he was able to say, hey, this radio interference is coming from outside the Earth. This is not somebody trying to jam our signals or anything like that. He had made the discovery that there were radio waves coming from the stars, particularly the Milky Way, our own galaxy. Now, not many people did much about this in the 1930s, but this young man, Grote Reber, I know, a rather unusual name, Grote Reber, he had studied electrical engineering in the United States, and he said to himself, hey, why isn't anybody doing much with this? This is an amazing discovery. And this was a 27-year-old man who had not really been into astronomy yet, but he realized that he needed to build a reflector dish to collect these radio waves and make some more important measurements of them. So he said, I consulted with myself and decided to build a dish because there was nobody else to talk to about it. So he did. He built the world's first radio telescope, the first purpose-built one. And he built this thing using sheet metal that were bashed out by the local car garage for him. And he put his receiver on top. And this was a scary thing to see. It's not scary now, is it? You've seen all these things before. Satellite dishes on people's houses. There's about 3 or 4 of them on the roof of my hotel. And they're everywhere around the world, right? This was the very first one, and people were so terrified by this that they would walk home from school or work using different streets to avoid getting too close to this dangerous-looking device. And I've spoken to some of those people who were alive then, who remember doing that. But it did not bother his mother. His mother actually hung the washing from it. So she was okay with it. She used it to dry her washing. She put the pegs on the side of the dish, and she was delighted to have this in her garden instead of an ordinary clothesline. Reber made quite a mess of the house, actually. He would damage the wallpaper by attaching his radio receiving equipment into the walls of the house. And so there we have a young Grote Reber standing next to his radio telescope in the year 1937, and he became the world's first radio astronomer. As I've mentioned, he had a lot of support from his mother. She even bought him a nice astronomy book, and he became known the world over. And he was very special to me because I knew him very well. He lived in Tasmania, Australia, for the second half of his life. And he wanted to observe the sky at very low radio frequencies. You know how you tune your radio? Well, it's all done electronically and through the computers these days, probably. But you tune a radio to different frequencies to hear different radio stations. And he knew that to listen to the sky at very low frequencies, you don't use a dish. You can't build a big enough dish to do that. So he put loads of wires up on poles. You can see his poles here on the ground at a place called Bothwell. And he had cows grazing around the poles because he was doing this on a farmer's property. He was really determined and did very, very well. He had many things that went wrong, in particular the cows. The cows would rub up against his equipment and damage his antennas. And one day he wrote, "Cow number 343 is a pest." Yeah, pretty bad cow that one was. An old aerial picture shows where he put his poles, and it's possible to make a measurement of this area where he had his poles. And we can see where the poles were because when we look really carefully at this picture, we see the shadows of them. So I've been able to measure the exact locations of these poles. I mentioned, though, that while he was working here, he did have a few problems. In fact, on one particular day, he was bitten by a platypus. Now, have you ever heard of a platypus before? The Australian animal. It's on our 20-cent coin. Great. They're lovely creatures, but Grote Reber didn't think they were particularly nice after he was bitten by one, had to be taken to hospital. So the determination that he had, he kept on. He wasn't put off by all of this sort of thing. So he put up his radio antennas up on these poles. He even used to climb the poles himself. He had special shoes made with things on them so that he could actually grasp the poles as he went up. And the end result of all of this was his radio map of the southern sky at a very low frequency of about 2 megahertz. You've probably heard of frequencies and megahertz and hertz and so on. This is really remarkable. Nobody had ever done this before. These are contour lines of radio intensity, a bit like on a weather map where you see the pressure of the air. Well, this is the radio intensity in the sky. And this is a really famous map from the centre of Tasmania. And he did a wonderful job. But it was his own determination. One man, he got some help now and again, of course, with putting the poles up. But one man was determined to get these results, and he did that. But what about ladies in astronomy? Traditionally, most astronomers have been men. But that's not the case so much anymore. And indeed, 100 years ago, or more than 100 years ago, this very famous lady, Henrietta Levitt, became the person who worked out the best way of measuring the distances to stars that were too far away to use that triangle. And she realized that if you take an object that is the source of light, like a candle, farther and farther and farther away, the candle is going to look fainter and fainter and fainter. Like this. And she actually found that there was a particular kind of star called a Cepheid variable star that helped her in her work. These stars rise and fall in their light output. And she made an amazing discovery. She discovered that the ones that were slowest to change actually were the brighter ones. So she had a way of translating the time it took to go up and down with how bright the star really was. And once she'd found that, she knew that when we look at it up in the sky and we measure its brightness, we therefore know how far away it is, because the farther away it is, the fainter it looks. So she put all of these things together like a jigsaw, and she worked out one of the most remarkable things in the history of science. That was in 1912 by a lady astronomer, 111 years ago. Wonderful, wonderful work. So there's the graph, the kind of graph that she drew with the brightening Cepheid variables having the longer periods. But what about today? Well, actually, right through history, there have been many female astronomers. Here's a shot that I took, I didn't take this shot actually, but this is a picture of a young lady who is an undergraduate at university in Australia. She is already publishing papers about the Milky Way. She is an undergraduate. She does not yet have her degree. That's the kind of enthusiasm that we love to see. But women in astronomy haven't always been treated all that well, and that's really bad, and it's good that things are changing. This particular lady, Anne Pine-Cowley, was a well-known astronomer as well. And she had a paper published in the Astronomical Journal just like Amelia Reed did, that young lady I showed you a moment ago. And she was just as enthusiastic. But she was told something really bad that should never be told. And that was that you have a husband who supports you, so you only need money for perfume and fur coats. That was how she was being treated by the establishment. And that should never happen, because these people are doing wonderful work. Has anybody ever seen the movie called Hidden Figures? Anybody? No. Right. Well, there's something else you need to watch. It's called Hidden Figures. You may not know this, but this lady called Katherine Johnson was one of the ladies who were doing the calculations for John Glenn's orbital flight, the very first orbital flight for the United States. Yeah. So behind all the work in engineering that was being done, she and other ladies were doing the calculations that made John Glenn's first flight successful. There's a movie all about her, and I want you to see that. I hope you can see that on, do you have Netflix and things like that in Mizoram, yeah? Yeah, see if you can get it on Netflix. Here's another young man that did a wonderful job, Clyde Tombaugh. He discovered Pluto. Have you all heard of Pluto? Right, it's not a planet anymore. Yeah, that's partly my fault, actually. But anyway, here we can see the pictures that he took that he used to discover Pluto. He found that there was a little point of light. I don't know whether you can see it clearly, but it's at the ends of those arrows. In 1930, that had moved from one place to another over a few nights, 6 nights. And he realized that's an object moving around the sun, and it's a long way away. And he'd found Pluto. And he was a pretty young man as well. But what about this young lady? She was 11 years old, and she took a great deal of interest in this. Her name was Venetia Burney, and here she is just before her 90th birthday. I went to meet her, and I went to meet her because she loved the idea of Pluto. And when she was an 11-year-old girl, 5 years or 6 years younger than many of you are here today, she suggested the name of Pluto. She said, why not call it Pluto? She told her grandfather. Her grandfather told the astronomers in America, and they decided that was a good name because Pluto was the god of the underworld in mythology, and the planet was distant and dark. So she became very famous. And coming down now, another couple of years, Marco Puzio, who is a boy who named an asteroid called Bennu, that's been visited by a spacecraft, and he won a competition to name it Bennu, because Bennu is a bird creature from Egyptian mythology, and he thought the spacecraft looked a bit like a bird. So he contributed at 9 years old. And I'm going to show you soon how other people can contribute as well. Now, I'm often asked about star naming, and the only actual authority that really does name stars officially is the International Astronomical Union. This is the world body of professional astronomers, of which I am a member. You might see some websites that say they will name a star if you pay them $100. Actually, they do name it, but they only keep it in their own database. Those names are not used by astronomers. I have to be careful what I say here. But seriously, astronomers only use the names that are assigned by the International Astronomical Union. And I'm going to show you one that I came across actually fairly recently. There's a particular part of the sky near the border of the constellation of the Sextant and the Sea Serpent Hydra. That location there, just near the S of Sextans, you can't see a star there because it's not actually marked on this chart. But that star, a few years ago, was given that name. And I hope I pronounce it correctly, Bipa. And it's named after an Indian scientist, Bipa Chaudhuri. And she was a particle physicist. And that's a branch of physics that deals with the very small particles, atoms, molecules, and much smaller than that. And she found the first evidence of a kind of particle called a meson, and she did that in Darjeeling. So it's wonderful that a star has been named after her. People sometimes have fun with some of these names, though. Actually, we have a lot of fun in astronomy. We really do. Astronomy is for everyone, of course, but we can all enjoy what we do. And sometimes there are some little practical jokes. And here we can see some stars that were named Suolokin and Rotanev. And for a long time, nobody could work out why these were called Suolokin and Rotanev. The names just stuck. Somebody mentioned them one day. And it turns out that they were named after Nicholas Venator, who was an assistant at the Palermo Observatory in Sicily, and they were just spelt backwards. That's all it was. So somebody was having a lot of fun. Here's another one that you can have a lot of fun with. Asteroid number 3142. Yeah. You all love maths, so you'll be well aware that pi, you know the number pi? Pi is one of my favourite numbers. You like pi? Yeah, right. 3.142, etc. So asteroid number 3142 was called kilopi, 1,000 times pi. I thought that was really creative. And here's another couple as well. Asteroids number 24,680 and 13,579 were called all even and all odd. Yeah, that was the name given to them. Yeah, lots of fun with that. I'd like to share a few remarkable pictures with you, and one in particular that's been sent back recently by the Emirates Mars mission. Now, the United Arab Emirates has a mission in orbit around Mars right now, and it's called HOPE. And just a few weeks ago, HOPE sent back this absolutely remarkable picture of one of the moons of Mars. There are two small moons of Mars. They're only about 10 or 20 kilometres across. This is the smaller of those two moons, and it's called Deimos. The other one is called Phobos. This picture of Deimos is the best one we have ever had. You've heard about all the probes that the United States has sent to Mars, I'm sure, but this one is the United Arab Emirates, and they've done better than NASA ever did getting a picture of this moon. And from this picture, and from the data that's come back about the details in the picture, scientists have been able to work out that it does appear that this moon originally is made up of material that came from the surface of Mars. So it probably was not a captured rocky asteroid, and it certainly wasn't a spaceship built by aliens. Seriously, some people have actually suggested that. No, it's not. But it does help us to learn about the origin of these moons. And that, of course, helps us to learn about the history of our solar system and the formation of all the different kinds of objects that we have in the solar system. And here's another mission to Mars that I hope some of you, or if all of you, have heard of. It's the Indian Space Research Organisation's mission to Mars, Mangalyaan 1, which operated up there between 2013 and 2022. Did you know that India was the first country in history to succeed in getting a spacecraft to Mars on its first attempt? Yes, your country. I think that's fantastic, I really do. Here's a wonderful picture that was taken by Mangalyaan 1 of Mars, showing one of its polar caps and plenty of detail on its surface, including a really long valley. You might just be able to see that from where you're sitting, just down below the centre of that picture, called Valles Marineris. Mariner Valley, named after a spacecraft from a long time ago. And there's something that I came across on the internet only recently. I have not got one of these yet, but it's a 2,000 rupee banknote. Have you seen this one? Right, I would like one. But I have been told by Professor Fente that apparently they're out of circulation now or not being printed anymore. So I'm going to see if I can find one. And this commemorates your wonderful space effort. I think this is absolutely fantastic. I know here in Mizoram we're in a quite different part of India. Yeah. But this is a wonderful Indian success. And we've had some amazing pictures come back from the James Webb Space Telescope, helping us to learn a lot more by looking at the universe in different wavelengths, infrared light that we can't see, that's helping us to see how stars are being formed in huge clouds of material just like this. And these wonderful space telescopes are showing us more detail in other galaxies than we've ever seen before. We're learning about galaxy structure, formation of stars. But as many of you are going to become scientists, I hope, yeah, what you will learn, if you don't already know it now, is that in science, when we answer one question, we usually get one more, or two more, or three more. It's an ongoing process. And recently, by studying not this galaxy, but very, very distant galaxies, the James Webb Space Telescope has come up with some really odd results, something really strange, that some of the very young galaxies seem to be more developed than we thought they would be. They've got more stars, they're more massive. This shouldn't be happening, according to our theories. So we've now got a new question to ask about the early period in the universe, and we never thought we'd need to ask this question. Let's get back a bit closer to home, though, because over the last 28 years, we've been finding planets around other stars. Did you know that until 1995, which of course to most of you here today was before you were born, but until 1995, we did not know of planets moving around other stars, only our sun. Oh, we assumed they were there, but we couldn't see them, we couldn't detect them. But in 1995, we started to detect them, and in a moment I'll show you one way we do this. This is just an artist's impression, a painting, of what a planet with an icy moon might look like moving around a star system way out there. There are several methods that we use to find these, but this has been the main one for many years now. And this is when a planet moves in front of its star, as seen from here. Actually, we don't see the disk of a star. The stars are too far away. So this is also just another painting showing what would happen if we were close up. We shouldn't look at stars, by the way, close up, because you can damage your eyes very badly, and that includes the sun. But this is the kind of thing that would happen. And as you can imagine, I'm sure, if astronomers just simply measure the amount of light coming from the star, it will drop slightly as the planet moves in front of it, okay? Good scientific method. And each time the planet goes around, the light will drop and then come back again. And that's how we found thousands of planets moving around other stars. That's just one of the methods, but that's what we're doing. And astronomers around the world are working on this. Not only that, we've had spacecraft doing it as well, several spacecraft. And now, as of this morning, we know of 5,381 planets moving around other stars. In 1994, we knew of 0, except for a couple that were moving around a strange kind of star called a pulsar. But we're finding planets at the rate of 2 or 3 every week. So they don't make the news much anymore, which is a bit sad, really, because a lot of work is being done. The fact that planets move around other stars is not a mystery anymore. We know they're there. But there are other mysteries. We don't know what dark energy is. Have you all heard of dark energy? Right. You might have heard of dark matter too, which is a kind of matter we don't see. But dark energy is a real mystery. What is it? You know, in 1998, it was discovered that the universe is not only getting bigger, which we knew for a long time, that expansion is getting faster and faster. Something is pushing the universe apart, pushing the galaxies apart. And we don't know what it is. It's in this room right now. Think about the neighbor sitting next to you. The dark energy is here. It's trying to push you all apart as well. But you can't feel a thing because dark energy, that force, is very weak indeed. But by measuring the speeds of other galaxies, we can see that the universe's expansion is accelerating. And we call this thing dark energy that's doing this. Maybe some of you scientists will help us understand one day what dark energy really is, because right now we really don't know. But in the theme of astronomy being for everyone, here's a friend of mine who is not a professional astronomer. He's got an observatory in the north of Tasmania, and his name is Merv Millwood. He's built an observatory. He makes measurements of stars. He writes scientific papers. He takes wonderful, wonderful pictures of the sky from his own backyard. There was a period not long ago when he couldn't take pictures, and that's because when he was walking to his observatory one night, he was bitten by a snake, and snakes in Tasmania are all quite venomous, and he spent some time in hospital. So there are some hazards in astronomy as well. But let's have a look at something that you can do, a couple of things you can do, to provide research information for astronomers. You may not have heard of this organization. It's called the American Association of Variable Star Observers. What it basically means is people who watch the stars getting brighter and dimmer for various reasons. And you can contribute to this as well. Yes, you can get onto the AFSO website. You can actually become a researcher in a way, because you can look at the stars and make these measurements with your own eyes and send them in. And the AFSO compiles all of these measurements from around the world. And as you can see, people's measurements are not always the same. But when you plot them on a graph and you've got thousands of them, can you see what's happening to this star? It's getting brighter and fainter and brighter and fainter. And a lot of this is done just by eye, by experienced observers, which you could become if you want to get involved in that kind of thing. But not only is astronomy for everyone, planetariums are for everyone as well. And I know that you have a planetarium near here. How far away is it, Professor Fente? About 30 kilometres, is it? Something like that? It's at the Science Centre. And I'm going there this afternoon, and I'm really looking forward to that. But this is a really special year for planetariums. Have you all been into a planetarium before? I'd say about 34% of you. Okay, right. Well, you've got one only about 30 kilometres away, and I hope you can go there sometime. Well, 30 kilometres outside of Aizawl anyway. Why is it such a special year? I keep saying that, and I haven't told you yet. It's because planetariums have been around since 1923. It's now 2023. It's our 100th anniversary. And here we can see the very first public planetarium being demonstrated on the roof of a building in Germany, the Carl Zeiss Works in Germany in 1923. And from then on, people have been watching. Actually, this particular picture was in 1924, but it doesn't matter. Planetariums began in 1923. I run one of these. Mine's all digital. Yeah, I use 8 digital projectors to project the stars up onto the dome, because that's what a planetarium's all about, making it look like it's nighttime, and we can point out things with an arrow torch or a laser and show people where the Southern Cross is, show people where important stars are and where the planets are. And there are several thousand planetariums around the world, thousands of them. Here's one that means a lot to me. It's a planetarium in Kharkiv in Ukraine. It's closed. The bombs have been falling all around it. The windows are broken. And my planetarium recently, here's their special star projector too. My planetarium recently formed a sister arrangement with that planetarium so we can keep track of each other's news, what we're doing. So I email them. Their email is still working, and I'm sure you will all realise that people in Ukraine are having a difficult time at the moment. So that's a really special planetarium for me. One of thousands, though. Here's a really clever one, the Bamboo Planetarium in Kenya, where people don't have enough money to build a planetarium. They've made one out of bamboo with a special screen up on the top of it, and they can just walk underneath this bamboo and see the stars projected onto the screen inside their planetarium. And I was given a lovely gift recently in Thailand. Thailand is very supportive of astronomy education, not in their own country, not just in their own country, but in other countries as well. And here we can see a special star chart made for the country of Laos, and in the Laotian language. The very first star chart of this kind, a planisphere we call it, that's ever been produced. Now, I began this talk by mentioning that I've fairly recently added "and space." Astronomy and space are for everyone. And that's because I'm becoming increasingly aware, as are people around the world, that there are problems out in space. There's the talk of militarization of space. There's lots and lots of satellites up there, and we're not really sharing the sky equally around the world. So as well as astronomy being for everyone, space is certainly for everyone as well. Of course, space topics are wonderful to look at. We first had an object in orbit around the Earth way back in 1957, and it was called Sputnik. And Sputnik amazed the world, annoyed the Americans a bit, because the Soviet Union had put something up before they could. And that started what we call the space race of the 1960s. But a colleague of mine in Tasmania actually photographed the light trail from Sputnik as it passed over Tasmania in October 1957 from the city of Hobart, where I grew up. I was not there then, by the way. But this was a remarkable picture to get. In 1957, there was one object in orbit around the Earth. Now look at what we've done. Yes, our planet now has several thousand active satellites and thousands more of bits of junk. Even a glove that's been dropped by an astronaut. There's a hammer floating around the Earth somewhere. There's pieces of rockets. And anybody heard of Elon Musk? Yeah. You might have heard what he's been doing to astronomers. Putting loads of satellites up there so that when astronomers are taking their pictures of the night sky, they often see these trails of light going right across their pictures because we're getting more and more of these satellites up there. Yeah, better internet coverage, but we're losing the wonder of the night sky. So these are the things we all have to think about. I spoke to you a little while ago about maybe going to Mars. I'm serious. I think some of you have a very good chance of going to Mars one day if you do the right training and so on. And wouldn't it be wonderful to have somebody from Mizoram setting foot on Mars? Yeah, that's a bit of a dream, but you never know. It could happen one day. But I mentioned astronomy and space are for everyone, and I'd just like to show you this particular part of one treaty about one object. It's part of the Moon Treaty from 1979, an international treaty that not every country has signed up to. The exploration and use of the moon shall be the province of all mankind. Actually, I don't think you'd say mankind these days, but this was 1979. And shall be carried out for the benefit and in the interests of all countries. Isn't that wonderful? Is it actually happening? Well, I'd like to think it's going to happen, but there's a lot of competition now to get to the moon and maybe use the resources on the moon. And because of that, the Artemis Accords have been drawn up. And Artemis is the name of the United States program to send people to the moon. There actually are going to be people walking on the moon in a few years' time. Now, I was around when the first people walked on the moon. You've all heard of Neil Armstrong? Who went with him? Who was walking on the moon with him? Does anybody know? Did somebody say Buzz Aldrin? I think maybe a few people did. That's correct. By the way, can anybody tell me the name of the third man who remained in orbit round the moon, waiting for them? The loneliest man in the universe. Yeah, his name was Michael Collins. Anyway, it was a very exciting time, but we're going to actually have people walking on the moon soon. And the Artemis Accords, you can download them from the web, talk about how we're going to all cooperate. And I think we should. Cooperation is very important because we don't want this kind of thing out there in space. We don't want wars. We don't want satellites being shot out of the sky. And that's all part of astronomy and space are for everyone. Here's a load of space junk. It's not a real picture, by the way. It's just a representation of all the things that you find out there. No doubt you'll find some discarded coffee cups, bolts and nuts and all sorts of things out there today. And another thing we don't want is the deliberate increase in the space junk. Yes, those little blue circles are circling little bits of debris from a Russian satellite called Cosmos 1408. It broke up, and it was broken up deliberately by Russia. Don't worry, I'm not anti-Russian. They're doing wonderful things in space. But this was rather irresponsible. And this is part of astronomy in space not being for everyone. I think that was a really bad thing to do. They had a lot of international criticism for that. From one satellite, we got 1,000 pieces to track because they blew it up. Here's a great example of cooperation. The European partners in the European Space Agency have just sent their mission to Jupiter called JUICE. It's nothing to do with orange juice, tomato juice, or apple juice. This is Jupiter Icy Moons Explorer, and this mission is going to teach us a lot more about the moons of Jupiter, because we've discovered that there is almost certainly an ocean underneath the surface of one of Jupiter's moons called Europa, and probably underneath the surfaces of Ganymede and Callisto as well. And this spacecraft called JUICE, is going to explore those moons for us, even going to orbit around Galileo, around Ganymede, I should say, Galileo. Okay, here's another example of wonderful international cooperation. Galileo died hundreds of years ago, by the way. Okay, here's another example of great cooperation. An Israeli instrument aboard this spacecraft is on its way to Jupiter now, and it's going to help to analyze Jupiter's atmosphere. So many different countries contribute to these fantastic space missions. Now, I wonder how often you look up at the sky. It's a bit cloudy lately, I think, isn't it? I think it was cloudy last night. Do you spend evenings indoors looking at the internet? Yeah, come on. I do too sometimes. Or TV, or something like that. It's good if you read books on astronomy and physics and science and things, yeah. But next time you're stuck in front of a computer screen, indoors at night, I want you to do this. I want you to stop doing that, because I want you to look at the stars. You know, so many people say to me, I heard there was an aurora last night. That's that wonderful glow of light that we sometimes see from Tasmania. Oh, I missed it. I said, well, where were you at the time? Oh, I was watching TV. Oh, great. Well, you've got to go out and look at the stars if you want to enjoy these wonderful things. And, you know, some of the best things that have ever happened for astronomy are where there have been power blackouts in big cities. If you were in the middle of New York and all the lights went out, you'd see the starry sky. Perhaps not exactly like this rendition, but you would see it. And indeed, some years ago, there was a big earthquake in Los Angeles. Big power cut. The whole city was blacked out. And you know, people in Los Angeles saw the Milky Way for the first time in their whole lives, because they'd never been in an environment where they'd had a dark sky. I know I'm running out of time soon, but I'd like to mention a couple more things before I finish. Here is India at night. Yeah. It's something we call light pollution. Yeah, a lot of countries have this. The lights go up into the sky, don't they? Where they're not really needed. They look spectacular from space, and from the hilltops in Aizawl, looking out over the lights of your city, it's really quite spectacular, actually. Not very good for astronomy, because the more light, the fewer stars you can see. But this is where you are, here, and look how dark it is here. Yeah, you are in a wonderful place to study the stars, to go out and look at the stars, because what you learn with your own eyes is absolutely wonderful. So here's a graphic showing you the big problem. Only about half of the light that comes from street lights is normally useful. Some of it is glare, and 40% just goes into lighting up the birds that are flying overhead. So what you need to do is to campaign for better street lighting too. It doesn't matter quite so much here, because you don't have so many street lights as compared with places like Delhi, Mumbai, and the really big cities around the world. And I mentioned a way you can contribute. Here's a graph that's been done, a graphic I should say, showing how little you can see from big cities. You've heard of Sydney and Melbourne, I'm sure, in Australia. Right over on the left there, not many stars at all, because the city is so bright. But as you get to places that are farther and farther away from the city lights, you see more and more stars. And you can participate in this. There's an international program in which you can contribute by making observations of parts of the sky. You can download star charts. You can count the stars that are visible to your eyes compared with the stars that are marked on the chart. And you can send in your observations. Every one of you here today can contribute to that. And we can learn more about the effects of light pollution around the world. And this is not just for astronomy. Lighting is affecting animals as well. There are so many things that happen when you've got too much light. I'm going to finish now, I promise, by mentioning something very important. And I think at the moment, the world has a lot of problems, sadly. I've mentioned one already about the planetarium that's my sister planetarium. But we share the sky. We all share that wonderful view of the sun, the moon, and the stars all over the world. It really does belong to us all. And I'd like to tell you a brief story about something that happened to a colleague of mine some years ago. He was out there watching the night sky with a friend of his, and he had his telescope set up off the side of the road. And he noticed that coming down the road were some rather aggressive-looking people riding motorbikes. He was quite worried about this. He thought he was going to get his telescope smashed up. He thought he was in trouble. And they came up to him and they said, "Oh, what are you doing here?" And he was really, really worried. But do you know what he did? Here are the bikies. He said to them, "Would you like to look through my telescope?" And they did. They looked through his telescope at the moon and some of the stars, and it changed them. They said, "Thank you for that. This has made our day. That's really great." So from an aggressive approach, he had made them into really peaceful people by showing them the moon through his telescope. Isn't that a wonderful story? And that's the way we should all be, I think. And that's where I'm going to finish. Here's a picture of the Earth looking over India, pretty much as it was a few hours ago. The clouds are all artificial, but there's our planet. We share it all, and we share the night sky. Thank you for having me here today. Thank you.
Thank you, sir, for the captivating, enthralling, and knowledgeable talk and insight on astronomy and, of course, space. I am sure it will go a long way in helping us understand the intricacies, wonders, and beauty of astronomy, as well as in sparking an interest in the science. May I request our speaker to kindly remain on the stage, and I would also like to request the chairman to kindly join our speaker for the interactive session with the audience. So we will be moving on to the interaction. All members in the audience are welcomed to put forward their queries or supplementations. If you have any questions for the speaker, please raise your hand and wait for the microphone to reach you. And kindly state your name and affiliation, that is your school or college, before asking your questions.
Good morning, sir. My name is Jonathan Nimrodkima from Dorpui Science School, and I have a question about why the Celestials are named after mythological gods. Can you please answer it?
Excuse me. Yes, the question was about why many objects in the sky are named after the gods and other beings from mythology. It's the way it has been for a very long time, because those gods were very revered in many cases. People looked up to them, and there were very, very detailed stories sometimes about those gods and the people they married and the children that they had and so on. And it was felt that the objects we see in the sky seem to relate to that kind of environment that encompasses us all. But they're not all named after gods now. You'll remember that the name Pluto was the god of the underworld, and that young lady, Venetia Burney, when she was 11, had been studying mythology, just like you're talking about now. And so she saw that connection between a distant planet and a god of darkness. And so that's really the way it's always been. But some of these objects have been named after other people. Some friends of mine have had asteroids named after them. And so there's a trend to move away from that now. Some moons in the solar system are named after Shakespearean characters, for example. So there's quite a variety now. Yes.
Thank you, sir.
Good afternoon, Doctor. Great speech, by the way.
Thank you.
My name is Lalan Rosarhalte, and I'm from St. Paul's School. And my question is, the modern world is advancing quickly, and many new inventions and discoveries have been made to increase our knowledge of our universe. Yes. And what do you think the world, in terms of astronomical advancements in astronomy, would look like in 100 years' time?
Oh, gosh, that is a wonderful question. What is it all going to look like in 100 years' time? It's really, really hard to predict. An old friend of mine, his name was Patrick Moore. He was a television and radio astronomer. In other words, he would communicate astronomy a bit like I do. And he often was asked this question around about 1940 or 1950 when he would give talks. And he got almost every answer wrong about what it would be like 50 years from now. And he was actually quite okay about that. He would go and give a public lecture and say, I got it all wrong. In 1957, I said this would happen, and it didn't. In 1961, I said this would happen, this would not happen, and it did. But coming back to your question, I have no doubt at all that we are going to learn a lot more about our universe, but two particular things I think are on the minds of a lot of scientists, as well as loads of other things as well. First of all, the beginning of the universe, the Big Bang. I mentioned to you that we have discovered recently, using the James Webb Space Telescope, that some galaxies appear to be too massive for their age. Something is slightly wrong with our ideas about the formation of objects in the early universe. And this is really important to us because we need to know how the universe formed in order to understand more about how the universe is today. So telescopes like the James Webb will tell us more about that. We'll develop our ideas and get them more and more correct, we hope, as we get toward the end of this century. But there is another thing that I think many of you must think about as well. Is there life out there somewhere? Is there intelligent life out there somewhere? We don't know. And that's something that we may get the answer to in the next 100 years. We're looking at places where there was once water on Mars. We're about to explore Jupiter's moons in more detail, where some people think there could be a primitive form of life under the ice of Europa, for example. And if we just had one discovery that there was life somewhere else, that would change us. I think it would change all of you. Just think about this, everyone. If I told you there was intelligent life on some particular planet like Mars, you would think differently about your whole lives, wouldn't you, about our Earth? What if I told you we just proved that there is no life anywhere else in the universe? That would change us because we would realize that we're definitely alone. And you know, one of those two things must be true. There's either life out there or there isn't. But when we talk about intelligent life, maybe we'll learn that there is intelligent life somewhere else over the next 100 years. I can already tell that there's a load of intelligent life in this room right now. It's absolutely fantastic. But what would other creatures look like? How would they think? How would they think about us? What kind of things would they try to tell us? And those people who this is a long answer, sorry, keeping you standing up.
That's all right.
What do you think we should transmit to other civilizations if we wanted to tell them about us, just that we're here? Or if you were an alien living on some other planet, a simple message. Here's a good one. Have you all done prime numbers? You know what prime numbers are, right? Okay, 2, 3, 5, 7, 11, 13, and so on. If you heard a radio transmission coming from a particular planet or another star, which was just prime numbers, yeah, you know what I mean. You'd realize immediately that that was an intelligent signal. It might not be telling you anything except that there are intelligent beings out there trying to say something. And that we know prime numbers just like they do, because prime numbers are the same all over the universe. So maybe sometime in the next 100 years, we might get a message that's just got prime numbers in it. And indeed, we once sent out a message using prime numbers multiplied together to make a little pattern, showing people radio telescopes and the human body and so on. Yeah. So they're two big things, but there's lots of others, I'm sure, and we're going to learn a lot more about our solar system too.
Thank you so much.
Okay. More questions? I'll let somebody who's got the mic take the microphone around. Pardon me.
I'm Himadri from Assam University, Silchar. Actually, I have two questions. Number one is, in northern hemisphere, we have North Celestial Pole, like pole star is there. But in southern hemisphere, because we belong to from that region, how difficult it is for an astronomer, particularly amateur astronomer, to actually find the direction in southern celestial pole? This is my question number one. And question number two is, you mentioned about 1969 Treaty of Moon,
Yes.
where Moon is for all, for mankind. But we know that some organizations are selling the land and the Moon. How, particularly, is it legally correct? What is your views?
Okay. Two very different questions. I'll start off with the southern hemisphere sky. Okay, do you all know the pole star, the North Pole star that you can see from here? Have you all looked at it in the night sky? Great. It's called Polaris. And it just happens by sheer coincidence to be in the same direction as the Earth's axis points in space, the North Pole of the Earth. So when you find the North Star, I've lost track of where North is in here, but let's pretend it's that way. You know where North is. We do have a star that is almost exactly aligned with our South Pole of the sky as well, but it's very faint, and it's called Sigma Octantis. And if you've got any light pollution at all, you can't see it. So you don't see it from the city. But we do have a way of locating south using the Southern Cross. Do you remember? I've actually closed my laptop down now, but do you remember the picture of the Southern Cross with the long axis and the short axis? Well, if you take a line from the top of the Southern Cross to the one at the bottom on that long axis and keep going about 4.5 times the height of the cross and stop, you are very close to that direction in the sky. So that is the general rule that we use to work out approximately south. And that's useful too if you're lost in the southern hemisphere at night and you've got no idea where you are. At least you'll know which direction you're walking if you can find south using the Southern Cross. But your other question about selling real estate on the moon, no, it is not proper and not legal. Nobody owns the moon. Somebody is trying to make money from this, and it's really very immoral and quite improper to be doing that, no. And I'm hoping that the various treaties that were put together, like the Moon Treaty, but also there's one called the Outer Space Treaty, there are several of them, can be updated to reflect the modern trends in the way people are thinking. Certainly, there is a great resource of raw materials out there in space. The rocky asteroids, for example. If we can bring that back to Earth, then we have a wonderful supply of materials. Who owns that material? And that's something that's very important to think about. Is it the first country to actually bring back bits of an asteroid to the Earth to use in making things? Or should it always be an international effort to do this? I think it should. So, but selling real estate on the moon? Absolutely not. No. When I buy my next piece of real estate, I can assure you it's going to be on the Earth, somewhere in Tasmania. So, yeah, it's not the right thing to do. Absolutely not.
Hello, sir. Yeah, my name is Dr. Rashid Zola. I'm a teacher in physics in the Department of Physics, Pachu University College, which is a constituent college of this university. So as an educator, what I have in my mind is from your lecture, can you kind of give a suggestion as to what kind of project we can take up with the students? Because looking at the facility available here in the Science Center, we have, I think, 16-inch Dobsonian telescope. And in our college, we have 10-inch Dobsonian telescope. So I've been thinking of a kind of project that I can take up with the students so that they will have some interest in the field. Like some simple suggestion, what kind of work I can do with the students.
Right.
Yeah.
Did you say it's a 16-inch telescope?
Yes, if I'm not wrong, 16-inch is the dia of the telescope there in Mizoram Science Center. The one we have at our college is 10-inch.
Okay. What sort of mount are these telescopes on?
I'm not exactly sure,
Okay.
sir. Yeah.
Right. With telescopes like that, these are quite powerful instruments. And in fact, a lot of really good work is done with telescopes of that diameter, that aperture as we call it. Do you happen to know whether there are any imaging devices, CCD cameras, with those telescopes?
Sir, as of now, CCD camera is not yet installed. Yeah, yeah. Oh, it has now been installed, yeah. Last time I visited that place, CCD was not yet purchased, yeah.
Okay.
That's correct.
There are lots of projects you can do with students with instruments like that. First of all, imaging of the night sky and learning how to stack images, for example, to get wonderful pictures of Jupiter, for example, or Saturn. Stacking software is very common these days. Have you used it before for any other purposes?
Yeah, sir, tracking software is available with that
Good,
telescope.
good.
Yeah.
What we're talking about there, everyone, is software that takes lots and lots of pictures and adds them together to reduce the noise in the image, to improve the color rendition and contrast and so on. So a project of astrophotography, modern digital astrophotography, I think will be wonderful for the students. And not only that, they can use that to learn more about the types of objects there are out there. Getting pictures of globular clusters of stars, for example, which are very, very old. They're billions and billions of years old. Looking at fine detail on Jupiter and Saturn, which you can do better with photography than you can with your eyes alone by looking through a telescope. Lots of people love to look through telescopes. I do too. But imaging is a wonderful thing you can do. But do you also remember that friend of mine who had the observatory? I mentioned to you his name was Merv. And he's done a lot of wonderful work in measuring the brightnesses of stars using something we call, you don't have to remember this term, it's called CCD photometry, meaning that the electronic imaging device itself can be used to measure the brightness of a star. So you could pick some stars that the American Association of Variable Star Observers are observing and make your own measurements. Do you know that using that technique, you might even discover a planet moving around another star when the star's light drops like that? So that's another thing you can do. But also, something that doesn't require the use of a telescope is to first of all visit a planetarium and learn about the way the sky appears to turn and watch the sky moving around us just to gain a bigger appreciation for the rotation of the Earth. And something that certainly is something I would recommend for primary students, younger students than we have here today, is that you can actually measure the rotation period of the Earth quite well with a telescope that you don't move because you wait until the object comes back into the field of view. And you can make measurements over many nights and average them so you learn how to use statistics in scientific measurement. There are just so many things you can do. Probably I could stand here for hours talking about them, but maybe we can talk after this session or something like that. But yeah, there's a lot you can do. I'd love to see these instruments sometime too. So did you say there's one of them at the Science Centre?
Yes, sir.
Right.
Yeah, the telescope is there at the Science Centre. I
Great.
think you're going to visit it this evening, right?
I'm going there later today, yes. So I'll look forward to seeing that. So thanks for your question, and maybe we can talk again about these projects. I can give you my card later and we can exchange some emails.
That'll be great, yes.
Yeah, great. Okay.
My name is Monique Ramdo Chapar from the SST, the Audrey School of Science and Technology. As you've mentioned about going to Mars and observing by satellites, and these days AI is really popular. I wonder if it is possible to observe Mars by sending AI robots. I want to know your opinion.
Okay. That's a really good question. AI is something we're talking about a lot, isn't it? Well, actually, in a way, we are doing that already because the robot missions to Mars have so much electronics on them, cameras and so on, that we are able to study Mars without actually going there. I'm not saying we shouldn't go there, but in a sense we are already doing that. It's not exactly the kind of AI that you're thinking of. It's not the AI that writes essays for you, which you shouldn't submit. It's the kind of onboard electronics that is able to make certain decisions, all by itself, using software. And an example of this is if you've got a craft coming to land on the surface of Mars, You can't control it remotely from the Earth accurately as it's landing. You can't pick a good landing spot where there are not too many rocks because the signal takes too long to get there and back. And when Mars is at its most distant from us, it takes 20 minutes each way. So if you had a picture of a rocky area where your spacecraft was about to land, your spacecraft sends you back that picture and you say, oh, we mustn't land there. Too late. It's already happened because it took that long for the signal to get here. So here's an example of what you might call a kind of AI on board the spacecraft that looks at the rocks and decides, no, we won't land there, we'll go over this way a bit, and actually searches all by itself for a place to land. But if your question is more about, should we just use those remote spacecraft? Should we really go there? Oh, absolutely, we certainly should. I'd like to go there. I don't think I'll go to Mars. Did you know something fascinating in my planetarium? The majority of students in my planetarium are upper primary. They're about 10 or 11 years old. And I have on many occasions been asked, Mr. George, have you been to Mars? And it's a serious question. Yeah, they think I'm some kind of spaceman. But no, I haven't been to Mars, by the way, just to make sure you all know that. Nobody ever has. But that's an interesting point. A lot of young people don't realise that people haven't done these things. Okay, I'll just finish off the answer here, sorry for that one. We do need to explore. And I remember one of the Apollo astronauts on the moon once said, mankind must explore, as he was walking on the moon. And I think we need to send people to Mars too. Having people there is probably going to tell us a lot more than even those wonderful instruments we've sent. Right, so we've got time, did you say, for one more? Yeah. Okay, one more question maybe. And there are about 5 hands up. Maybe somebody could select a person to ask a question. The man with the microphone, okay.
Good afternoon, sir. My name is Sarah Tansangi from Primary School. My question is that, what would happen if the moon left its orbit around the Earth and the Earth's gravity pulled the moon towards itself?
Sorry, I couldn't quite hear your question there. Could you say that again with a big voice?
My question is, what would happen if the moon left its orbit around the Earth and the Earth's gravity pulled the moon towards the Earth?
Okay, if the moon left its orbit or it came too close to us?
If the moon left its orbit and came close to us.
Oh, okay. In other words, if it came in toward the Earth. Oh,
yes,
okay.
Sir.
Right. Well, first of all, it wouldn't be a very good time for us. No. But more importantly, I can assure you that that would not happen. And in fact, the reverse is happening. The moon is getting farther and farther away from the Earth. Now, the reason that is happening is mainly because of something we call tidal friction. And what's happening, you know about the tides in the oceans? Yeah. You don't border onto an ocean in this state here, do you? But I'm sure you've seen tides before, you know about tides. Okay, the gravity of the sun and the moon. Mostly the moon is causing the Earth's oceans to be distorted. So as we turn around, the water looks like it's rising and falling. But what's also happening is that there's a friction between the solid Earth and this lump of water. And it's slowing the Earth's rotation down. Now, you all study physics, don't you? Yes? All right. It's something to do with angular momentum. Have you heard of angular momentum? Yeah, great. Mostly people up the back over there. People on this side have heard of angular momentum too? Right. Have you heard of conservation of angular momentum? Right. Isn't it wonderful you're learning all these things? Now you can see why it's so important to know about them. Right. As the Earth's angular momentum changes, the moon's angular momentum in orbit changes as well, and it's being effectively pushed out into a higher orbit. It's getting farther away from the Earth at the rate of, wait for this, 3.7 meters every century. Yeah, every century. So after another 100 years, the moon will have moved away from the Earth, farther, about the distance from me to the people in the front row. That's all. And isn't it wonderful that we can measure this by the instruments left behind from the Apollo astronaut missions, for the Apollo astronauts from 50 years ago? Okay, so the moon is getting farther and farther away. Eventually, a long, long time from now, the moon will be orbiting the Earth about once every 48 days. It'll be much farther out. We won't have any total eclipses anymore because the moon won't be big enough to cover the sun anymore. And our rotation will be about 48 days long. So if you think there are not enough hours in the day, you wait until that happens. Yeah, you'll have plenty of time. Unfortunately, before that happens, the sun will have got so hot that it will have burnt the Earth to a crisp, all the oceans will have boiled away, and we won't be able to live here anymore. That's a depressing thought, isn't it, for a Friday afternoon? But anyway, coming back to your question, now, the moon won't actually come close to the Earth. But if it did, there would be all sorts of problems with the angular momentum of the Earth, eventually, if the moon got so close to the Earth that it collided with us, that would be the end of civilization as we know it. And we know, for example, and this is an interesting one just to finish on, you've all heard of asteroids, those rocky objects that orbit the sun. Most of them are fairly small. There are some that are tens or hundreds of kilometers across. They do hit the Earth sometimes. And our big problem is not the really big ones. We know all about those and where they're going, and they're not going to hit us. It's the ones that are much smaller, the ones that are about 1 or 2 kilometers across. We haven't discovered them all yet. We know that. And they do collide with the Earth about once or twice every million years. And a friend of mine once did the calculation, my friend, Dr. Duncan Steele, and worked out that on the average, if an object about 1.7 kilometers across hit the Earth, that would be the end of civilization. 1.7. Less than the distance from here to the center of the city. And that's because of all the material that would go up into the atmosphere, blocking off the sunlight, setting forest fires alight because of the energy of the impact. But fortunately, we have programs all around the world to try to find these things, to locate them. And one thing we did last year was tested for the first time, when I say we, it was the United States. They sent a spacecraft up to deliberately collide with an asteroid, and it was a moon asteroid, a little one orbiting a bigger one. And they measured the change, and they changed its orbit. For the first time, September last year, September 2022, the human race actually changed the path of a celestial object. And being able to do that means that if we know that something's heading toward us and it's dangerous, we have the ability to push it out of the way long before it gets here. So studying these objects, learning about their orbits, whether they're coming toward us, is a very important part of astronomy. But don't worry about the moon. Enjoy looking at it, though. Okay, thank you.
Thank you, sir.
As a mark of our respect for accepting our invitation and granting us the privilege of your presence, the organizing committee would like to present Dr. Martin George with a small token of our gratitude. To do this honor, may I call upon the Vice Chancellor of Mizoram University, the Honorable Professor Dibakar Chandradika, to kindly come on stage. Ushers, sir, please stay on the stage.
No, I stay here.
Yeah, please come.
This is a way of honoring our guest.
Wow. It's really cool. Oh. Wow. So I am now a Mizoram person? Thank you so much. That's lovely. Thank you.
We're very sure that there would have been more questions and we could have gone on the whole day. However, because of time constraints and as we're already lagging behind the schedule, we would move on to the next program. To showcase the Mizo culture, may I have the pleasure of calling on stage the Hersey Cultural Club from the Department of Mizo, Mizoram University, to present one of the most popular cultural dance of the Mizos, Tero. Tero is believed to have existed since the 1st century, and earlier it was performed as parts of rituals to provide peace to the departed soul of a mother who had left her newborn child. Now, however, the dance is performed on various festive occasions, such as the Taptarkut, a springtime festival. It was also performed on the occasion of Buza'ai, and essentially it is a dance performed with a few selected girls with exceptional abilities rather than a community dance. Because this dance is performed with long bamboo staves, it is often referred to as bamboo dance. The dance steps are inspired by the movements seen in nature, such as the swaying of trees and the flight of birds. Thank you, Herse Club, for the beautiful rendition of Terror. May I now have the privilege of inviting the Honorable Vice Chancellor, Mizoram University, Professor Dibakar Chandra Dekar, to kindly deliver his address.
Namaskar, ladies and gentlemen. It's my privilege to be with you. And first of all, I thank the Department of Physics for organizing this seminar on astronomy of Mizo people. Actually, in schools or colleges, I have read about, heard about Indian astronomy. Of course, Mizoram is part of that. Whatever records shows in Indian astronomy, how much of the Mizo astronomy is included, I don't know about, but I would like to know. And therefore, I will request the organizers that you collect, publish all the papers on Mizo astronomy and kindly give me a copy of the collection so that I will be able to learn something about Mizo astronomy. Our honored guest, Dr. Martin George, he has delivered a long lecture to our youngsters. First of all, I welcome him to Mizoram University, and I thank him for his visit to the university and interacting with our youngsters, our young students, young generations. Respected ladies and gentlemen, my colleagues and students, probably I don't have much time now, but I have come here with my keen interest to share one information with our youngsters. I am told that students, of course I can see in front of me, our students from different college schools of 11 and 12 standards has gathered today here. And it is a very unique opportunity, I can say golden opportunity for me to talk, to share few information with my with the students. Before going to that, what I am going to share about, I will say one thing is that all of you have heard to Dr. Martin George. He had talked about in the lot of things about the universe, about astronomy. Even then, I will say that our youngsters are very good in imagination. And we believe that imagination has no boundary. But still, I will ask one question to our young students. How long, how far can you imagine? Imagination has no boundary, but still I will think how much, how long, to what extent you can imagine. Do you think there is anything beyond imagination? This is my question. Do you think there is anything beyond your imagination? If I guess, answer is, if there is anything beyond your imagination, there is universe. Universe has no limit, no end. You go on thinking, not 100 light years. Go about thinking millions of light years, billions of light years. Still beyond that, there is universe, what I believe. And whatever we know about astronomy or universe, this is a very small part of. We are still confined to our solar system. So, my request to young students, if you have adventure to do in future, you do not find much in the Everest, already explored, lot of things documented. You can find lot of adventure, lot of new things in the universe only. Still many things to explore, many things to discover in the universe. So those who are really have keen interest in astronomy, please go forward. You can find lot of advances, lot of new things, plenty of things to discover in the universe, which we cannot imagine. Our life is very short, not more than 100 years. But already you have explored the law of 100 light years up to the distance. Still, with this type of technology and advancement, still very small part of universe you have learned about. So that is one thing. Secondly, the purpose I am standing here to talk to students, share with students, is that how many of you know about International Astronomy Olympiad? I don't know, because I have been associated with that for last 20 years. There is 4 Olympiads, international Olympiads are there. One is International Physics Olympiad, International Chemistry Olympiad, International Biology Olympiad, and International Astronomy Olympiad. And every year there are tests is held. Several in this Olympiad, several countries over the globe they participate. So first screening test is held in the context of India. First screening test is held in the first half of, applications are accepted in the first half of September every year, and that is called Indian Standard Examination. That is standard examination is conducted by Homi Bhabha Center for Science Education, head office in the Mumbai. And that is funded by mostly DST, Government of India. So if you, from that examination, all of the students from 11 and 12 standard, they participate in the examination. And from that examination, 1% of the students are selected for next stage. That is held in every part of India. So I don't know whether any examination in the past was held in Mizoram, but in Assam, first time I organized when I was in university, Guwahati University. Then it is still continued. And there are not many participants from Northeast particularly. I don't know how many of you know in Mizoram. That is one. From the 1% of the first examination, Indian standard examination, national standard examination, from that examination 1%, there is a Indian National Olympiad, second stage. In the second stage, selected centers in the all over India are held. Your nearest center can be Calcutta. If number of people, students is large, then we can organize a center in Guwahati itself, which is nearer, closer to Aizawl. So from that examination, nearly 30 students are selected from all over India. The 30 students are invited for a 1-month rigorous training in Homi Bhabha Center for Science Education at the cost of the Government of India. All expenses, lodging, food, everything will be transport, means your to and fro journey, everything will be borne by the Government of India. And 1 month rigorous training, about 4 weeks, rigorous training is given in Homi Bhabha Center for Science Education in Mumbai. From out of the 30 students, 4 or 5 will be finally selected. And that 4 and 5 students will be sponsored to participate in the International Olympiad, which will be held in different countries. Next, I don't remember. We have to see in the Google search where it will be held in next year. But last 2-3 years, it was little bit disturbed due to COVID pandemic. Anyway, but it will continue. So same thing applicable for all the 4 Olympiads: Astronomy Olympiad, Physics Olympiad, Chemistry Olympiad, and Biology Olympiad. So this information I want to share with our students, and you share with your friends. And I'll like to request the Department of Physics in Mizoram University or Department of Physics in Pasunga College, Constituent College, to facilitate the students. In Mizoram, there may be 30, 40 colleges or there may be several schools who are imparting 12th and 11th standard. So if somebody, some department, Mizoram University Physics or the Pasunga Physics, they come forward and facilitate the students to appear this examination, this will be a great help for the future scientists in physics, biology, chemistry, or astronomy. And this will be a very good extension activity of the university or the college. So if students are interested, they can Google search also. They can go to Homi Bhabha Center for Science Education website, and many information will be available. And in the future, if opportunity comes, I would like to talk to students particularly, would like to share my experience with them. So I think I will not take much time. I'm happy to share this information. I hope some students will come forward to appear the next examination, which will begin in the first half of September. Thank you very much. Jai Hind.
Thank you, sir, for the enlightening speech, which was really knowledgeable. And now to conclude our program, may I request Professor Zai Tanzao Patsao, Head Department of Physics, to kindly deliver the vote of thanks.
The 2 days International Symposium on the History of Astronomy of the Mizo people is jointly organized by the Department of Physics, Mizoram University, and Mizoram Science Center, Directorate of Science and Technology, Government of Mizoram, and also in collaboration with the Office of International Affairs, Mizoram University. So as we have heard earlier, we are forming a triangle of this coordination so that the 2 days event is successful. I would like to express our heartfelt gratitude to our Honorable Vice Chancellor, Mizoram University, Professor Diba Chandra Deka, for kindly allowing to organize this event in the form of financial assistance and also giving technical support for this event. Today, on the request of the organizing committee, so the Vice Chancellor is present here and giving important message to the students. So, sir, we convey our gratitude for kindly allowing the financial support from the university. I would like to thank the Directorate of Science and Technology, Government of Mizoram, for giving additional support, because without the financial support from the state government, we cannot organize this symposium. So we are grateful to the Directorate of Science and Technology for giving financial support and also logical support, because as we know that in the afternoon, we'll visit the planetarium in Mizoram Science Center at Birotlang, where there will be interaction again in the afternoon. I would like to convey our heartfelt thanks to the Chief Scientific Officer, Engineer Aisla Somliana, who is the chairman of this function, and all his staffs for making a success to organize this symposium. Today we had an interesting and wonderful lecture from our keynote speaker, Dr. Martin George, Principal Astronomer Hive Planetarium Tasmania, Australia, and chair of the International Development International Planetarium Society. Thank you, sir, for giving an interest lecture from yesterday. Today also, I hope that your message and lecture will give inspiration to the students. We'd like to also convey our heartfelt thanks to the chairman, the speakers, the panelists of yesterday's event in the technical session, because in the yesterday's event, the senior these academicians and also from the civil society, they are participating quite large in number. So that shows that astronomy is for the society, for everyone. We'd like to convey our gratitude to the Mizo department of this university, because yesterday all the students of the Mizo departments are participating along with the faculty. Today also, the Hersey Club of this Mizo department is participating in the form of cultural item. We'd like to thank the directorate and staffs of the Office of International Affairs of Mizoram University, because of the efforts of this office, our keynote speaker, Dr. Martin George, could come to Mizoram University because of the continuous efforts of the Office of International Affairs, because we know that last year they have met in Bangkok. So because of their constant effort, so we could get Dr. Martin George here in Mizoram. Thank you for the coordination with the Office of International Affairs, Mizoram University. Last but not the least, I'd like to thank the teaching faculties, staffs of Department of Physics, Mizoram University, all the ushers, all the backbone workers behind the scene who are not able to be seen here today, but they are working instantly from the last 3 to 4 days for the success of this symposium. And I'd like to thank all the students who are participating today from the higher secondary schools from the city, and the students from Pachunga University College for coming here in the university campus. Without your participation, this event will not be successful. Thank you so much for coming here and make the event successful. Thank you.
Thank you, sir, and thank you to all the participants who have made this program a success. Special thanks to our speaker, who has really enlightened us and really struck our minds in relation to astronomy. We have a few announcements here. For the registered participants, certificates can be collected at the reception counter. For the school participating students of each school, the certificates may be collected collectively by a single teacher, one teacher. Then regarding the photo session, we will be having a school-wise photo session with the speaker. Dr. Martin, if you can kindly remain to have the photograph. Yes, please. We will be calling you school-wise, and then you can go on stage for the photo.